Radical expressions and equations, addition and subtraction with radicals. The way we add or subtract radicals is just the same as if we were to add or subtract like terms on, say, a polynomial. For this first example, we have 7 times the square root of 5 plus 3 times the square root of 5. We can see that our radical is the same and both 7 and 3 are real whole numbers. So we could just add those together. 7 plus 3 is equal to 10 times the square root of 5. And that's our answer. Here we have 9 times the cube root of 2 minus 7x times the cube root of 2 plus 4 times the cube root of 2. Our radical in each one of these is the same. It's cube root of 2. And here we have two whole numbers, 9, and we have a 4. But this one, that one is 7x. It has a variable next to it. So we can't add the 7x to the other two terms. But those two, the 9 and the 4, we can add them together. And that would give us 13 cube root 2. And we would leave the 7x cube root squared alone. And this would be our final answer. Here we have 3 radicals, but the difference between these radicals is that inside of the radical we have 4x on each term, but the index is not the same on each one of our terms. So here we have a 3, here we have a 5, and here we have a 5. That means we can add the first two together, but we cannot add the last one. When we add the first two, we get 8 plus 2 is 10. That's a 10 in case it looks sloppy. That's a 10. 8 plus 2 is 10. The fifth root of 4x minus the 4x, or the cube root of 4x. And that is our final answer. This last one takes a couple more steps. We see that the inside of our radicals are not the same. So the first thing I want to do is I want to see if I could simplify any one of these two. The first radical, I know that I can factor that out. 16 is the same as saying 2 cubed times 2. Because we know 2 cubed is equal to 8. And when we multiply it by 2, we're going to get 16. So I'm going to factor this out. 5 cube root of 2 cubed. We have a y to the 4th. That means we can factor out a y to the 3rd. Y to the 3rd. And then we're going to multiply this by what's left over. So we're left over with a 2 and 1 y. And obviously this is adding 7y cubed square root of 2y. Oh, wait, this isn't, well, the y isn't cubed. It looks cubed, but the y is, or the 3 is in the radical. Now we can simplify this first term. 5 times the 2 cubed in the cube root. That's just going to become a 2 on the outside. And the y cubed on the cube root is going to become a y on the outside. We're going to multiply this by the cube root of 2y, and then we're going to add 7y times the cube root of 2y. Now we see that both of our radicals are the same, and even our terms are the same. We have a whole number multiplied by the variable y. 5 times 2 is 10y cube root 2y plus 7y cube root 2y. So we can add these terms together because now they're like terms. 10y plus 7y is going to be 17y. We're going to leave our radical the same. It's the cube root of 2y. And that is our final answer.